Hello everyone, today we're going to talk about heating curves. A quick review of what we already know about energy and heat. Energy is a measurement of the ability to do work or to produce heat. Energy's most common unit is joules, and heat that enters a system is used to either increase the average kinetic energy of the particles or to break the interparticle forces that are present. Usually heat is only capable of doing one of these two functions at a time. This is illustrated by looking at a heating curve. If you observe here in the heating curve, temperature is constant while a substance is undergoing a phase change. For example, while water is boiling, its temperature will be 100 degrees Celsius, assuming we are, of course, at sea level. The result is that if you try to graph temperature versus the heat added for a substance while going through temperatures where phase changes will happen, you'll end up with what looks like a piecewise function, where if you start off in one phase, you'll have what appears to be a straight line up to a point where you reach the temperature of a phase change. There will then be a horizontal line until the phase change is complete, and then afterwards there will be another line, etc., through the phase changes. Therefore, because this is a piecewise function, we should handle temperature changes and dealing with the heat added to a system like a piecewise function. When temperature is increasing, aka the slanted segments that are lines, the heat is being used to increase average kinetic energy, hence why the temperature is rising, because temperature is the measure of average kinetic energy. In this case, to calculate the heat, we should use the equation Q equals mc delta T. Where the temperature is constant, the heat that's being added is being used to cause a phase change, which means it's being used to break apart interparticle forces, either IMFs or bonds. In this case, we should use the equation Q equals m change in enthalpy of a phase change. Let's look at an example problem for how to do calculations involving multiple pieces. 100 grams of water sits in a pot at 20 degrees Celsius. The pot is then heated until all of the water evaporates. The specific heat capacity of water is 4.184 joules per gram degree Celsius, and its heat of vaporization is 2,260 joules per gram. Determine the amount of heat energy required to complete this process. So for this process, we might want to consider, where on the heating curve are we? What pieces do we go through? In this scenario, we have two pieces that we go through. We go from the 20 degrees Celsius, which is close to room temperature, up to 100 degrees Celsius, the boiling point for water. At that point, the water boils, and our prompt says that we stopped monitoring once everything had boiled. So there are two pieces, and therefore we have two heats we will need to calculate and then add together. For the first one, since we're dealing with a temperature change, we're going to use Q equals mcat. For the second one, since we're dealing with phase change, we'll use the mass times the heat of vaporization. Let's do the first one. For the heating up process, we are heating 100 grams of water from 20 degrees Celsius up to 100. So we would set up our work like so and calculate the amount of energy required for this. We will need, rounding to appropriate sig figs, 33,500 joules in order to complete this process. We'll pause on that one for now. We will need this number for later. Our second process is the boiling step. So again, we're taking the 100 grams of water that has now reached its boiling point. We'll multiply that by the heat of vaporization provided of 2,260. When we multiply these, we get that for this process, 226,000 joules will be required. Now that we have the energy from the two pieces, we must add them together. So we take the heat to get for the temperature change, plus the heat needed to undergo the phase change, add them together, and we get that 259,500 joules will be needed in order to complete this process. So Our general summary of how to handle this. We should assess a process when we're given a prompt like this for the number of pieces. You may find that, like in previous examples, there was only one piece, and so you only need one equation. Or you may find that there are multiple processes occurring and you will need multiple pieces. Then, you will calculate the heat for each piece, paying careful attention to which equation you use for which piece. Reminder that temperature changes need the MCAT formula, and phase changes need the mass times the heat of vaporization one. Then, once you have the heat from each piece, you add up all the pieces to get the total heat required for the overall process described.